Now let's talk about some problems. Now, what's the number one problem? We're going to run across little or no drainage. Dead or dying plants, another problem. Weeds, again, our friends the weeds, big problem. Little or no water entering the rain garden, litter and blowouts. I'm going to cover all these. But these, and if somebody else can think of a problem I didn't think about, please raise your hand and say, what about this? Because these are the most common ones I've come up with. All right. I looked at that and I thought that looks like that the North Korean leader pointing to his people. I like that I took that picture. So what's that guy, King Jong-il? Anyway, so this is a rain garden. We had to build this to control the water off of that basketball court in a fellow's backyard. And right away, you can see we're in red clay. We're in a red bed. Okay? Not going to naturally take the water itself. It will, but it's slow. Clay does absorb water, but it is slow. We will do, if you're a design professional, one of the things you should do, which is very, very hard to do because nobody's going to pay you to do it, is you should be on that site doing borings and using a double ring infiltrometer and or doing perk tests. Okay? You tell your client, oh, hey, by the way, I need to do perk tests, and in the meantime, they're looking at you like you're from outer space. We're not paying for that. Okay? However, you should be doing it. If you're in a situation where you can check the soil percolation prior to design, you should be doing it. Sometimes it's impossible because the site doesn't exist. A lot of our commercial constructions are cut and fills. Okay? If you're designing on a cut and fill, locate the rain garden in the cut portion as opposed to the fill, to the fill portion as opposed to the cut portion, as long as you're not encouraging a failure, oversaturating a piece of the fill, depending on where you can locate it. This particular site was horrible. We actually, we got under drains that are coming under this, or springs. There was a storm when we built this. This thing literally filled to the very top of the water over the weekend after I dug that out. That much rainwater over one thunderstorm. One of those 2-inch, boomers that came, filled that pit the next day after that photograph was taken. So you get a lot of water running off these sites. Now what you're looking at is you're looking at the overflow, the outfall, you're looking at the underdrain. And you're also looking at seeing bad soil. I knew the soil character here, so when we designed this and submitted it, we did include underdrain. This is another attentive grading area. We actually hit groundwater. That trench, that's grass. That trench is only 2 feet deep. Then when we were excavating, we hit groundwater. So, fortunately, this also had an underdrain, but people talk about failures. Some of these failures need to be addressed front end. Okay? If you are the municipal official, you are the engineer, you want to kind of keep an eye out for that. Now, this was not a, this was one wet area of a trench that was 100 and some feet long. We really didn't do anything here. All right? But it was curious to me that we hit groundwater 18 inches underground on it. And literally, it was a road bench and it was a slope, big slope. So existing soil conditions are critical to understand when you're doing a successful rain garden. Excuse me. This is a construction site where the rain garden soils were provided by the site contractor. The weir and the overflow was put in, inlet pipe, and then the soil was placed, and then it became a storage area for construction debris, pile of dirt, This is a common problem. People tell me, oh, we had a problem, this is failing, what are we going to do? You know, blah, blah. And so, when did you put the soil in? Well, the site contractor did it. The site contractor's job is to get the site on grade, put in the utilities, get ready to build a building, or parking lot, or park, or whatever you're doing. The soils in this rain garden are the carpeting for the house. You don't put the carpeting down before you build the house, because you know what happens? Carpet gets ruined. Same thing here. These rain garden soils should not have been installed until that paving was ready to be installed. Sequence of events, I always tell people, either get the paving done and then put the rain garden soils in, based on logistically how you get the trucks in, the triaxle trucks, big heavy trucks, so that you're not crushing the curbs and breaking, ruining the asphalt. Or you put this rain garden soil in just before you're putting the gravel and stone down for that parking lot. Okay? Because you're going to keep, you need to keep this soil clean, because it will lens. It will take silt over the top of that rain garden soil. It will form a lens that will keep water from percolating, especially in a heavy clay site. Okay? So from a maintenance standpoint, what's the point when you have a rain garden that's not performing properly, holding water? One of the first things you want to do is go out there and take a shovel and start kind of dig a few holes in this thing, rough it up. One of the great things about planting with all those plugs is you're actually turning all the soil up, getting that little bit of a lens, potential lens, broken. Okay? We're going to talk, again, we'll go back to this whole Geo Textile thing. This was actually not an infiltration trench. We were actually exfiltrating out of this. This trench was taking water off the street into a gravel trench, and then the water was going out of the trench into the soils. There was a little bit of a retentive grading dish on top that takes some runoff water, but we weren't getting a lot of runoff here. So this particular situation, the water was going into the pipe and pushing out through the Geo Textile. Theoretically, it's going to keep it clean. If we were trying to infiltrate into that gravel, this Geo Textile has a very, very, very high probability of getting plugged. When you have failures in a rain garden and you have an issue, the very, very first thing I always ask anybody is, did you have Geo Textiles? Were you using Geo Textiles? Most of the time that answer is yes, and we tell them, well, guess what you got to do now? Cut the stuff full of holes, dig it. One great thing about this stuff is it burns like the dickens. So if you dig a hole and you take a roofer's torch and hit that with a roofer's torch, it'll burn big holes in it really nicely, so you don't have to dig it all out. But you want to essentially, if you're dealing with a situation where you're not getting drainage, you've got Geo Textiles, you need to get that Geo Textile out of there, and or you want to interrupt it, burn holes in it, do something to it. Okay. I use this as an example of Geo Textiles in the rain garden, but this particular situation, most of the water was infiltrating out of that. Here's an epic failure of a retentive gradient area. There's no under drain here. This was a series of trenches above a big hillside, and this was probably 40 plus feet long. This was the second to the last in a series of about 15 of these that went up the slope. They all were excavated the same way. They all were built exactly the same way with the same soil mix. That one wouldn't drain. The one up from it drained. The one down from it drained. Okay? You can see on my shovel I shoved in there, that water line was here. This was we had our 24 inches of rain garden soil. It was completely saturated. Right, we did 18 inches, we had a little bit of freestanding water. Completely saturated. The underlying soils would not take the water. Okay? We could have made one of these. And that's what this is. I built this, I dug this. Pulled it under, we dug a big old hole. Ran around a little bit. And what did we end up with? A pond. Because I knew where the wet spot was. All right? That, we could have dug a pond. But now instead we needed to be a retentive grading area, so we had to fix it. So on that particular project, we had multiple. Here's another one. You can see where the grass died. It infiltrated, but it infiltrated very slowly. So the solution I used, and I got in a nice fight with the engineer on this, but I've done this a number of times and it does work, is we have very large augers that we use to set light pole bases in parking lots. We augered these rain gardens, these we call these retentive grading areas. We augered these trenches. And then filled this with sand. I've also filled them with gravel. And what's happening is I'm going 8 feet in the ground here. I'm hoping I'm going to interrupt a stone layer or shale layer or something that's going to take this water away. And we were able to fix all the slow ones that we had with this technique. What was interesting, that is what came out of the very bottom, 8 feet deep. It was solid clay. The design team, from what I understand, did one test pit. We had, I can't remember now, many of these trenches, and they were all very long. Some of them were up to 200 feet long. They did one test pit on one side of the road and one test pit on the other. The state of Maryland's recommendations in their BMP manual is you have to do one test pit every 50 feet. Okay? So, if you're a design professional and your client will not pay you to go out there and do the proper testing, then you need to make sure that you put in your proposal, or you put in, we're not guaranteeing this thing's going to work. You can't. Unless, of course, you can underdrain. If you underdrain it, you're okay. But if something like this with no underdrain, you're taking a risk that you're going to have failure. The solution for most all these was augering and filling those with sand. I've done this on several times on rain gardens. We just, we didn't have any underdrains, and these things wouldn't move water. We can get deep enough, we can typically get into some rock, and we can move the water away. Now, people all of a sudden say, oh my God, you're polluting the groundwater table. You're doing this, No. We're not polluting the groundwater table because, we're only going to be in the ground 8, 9 feet. If you ever drilled a well, if anybody's ever lived in a well, your house wells, you got good water, shallow, it's 120 feet. Okay, I still got 90 feet of rock for the water to get through before somebody's going to pull it out of the ground. Obviously they go down to about 300 feet, build a house well, and if you go much below 300 feet in most areas, you end up with bad water that's got salt in it, in western PA, depending on where you're located. But it's interesting to see that there wasn't a stinking rock anywhere here. 8 feet of solid clay. And they actually still drain. They just didn't drain quickly enough. Short on time here, stop talking. Okay. Now, this was an underdrain that was installed on that one that I showed you with the shovel. Okay, this is a product called Smart Drain, very cheap, very easy, scratch it in, and this is a 2-inch pipe, and boom, that one's working great. Now, here's another rain garden, water retention area. This has standing water in it, but guess what? They put a line in it. So before you're the maintenance guy and you're saying this is a big disaster, you're going to start poking holes in the thing. Get the drawings out, find out what these guys are trying to do when they build it, because we built a number of these that actually have a liner in them because we want to hold water. We're just buffering water between the outfall and on the edge. We're doing our absorption on the top unprotected edge. Quickly, time of year. This is a rain garden. It is in a meadow. It's standing water. It's standing water because that picture was taken at the end of March. Ground's still frozen under there. You'll get a lot of calls if you're the maintenance, you're doing this. You'll get a lot of these March, early April calls saying, we got a problem, we got a failure, it's got, we got these issues. Especially in March, early March, you'll end up with frost. It's still on the ground after a cold year like last 2 winters we've had, down in the negative teens. We've had 24 to 30 inches of frost getting in the ground in some areas, especially in that soil. I passed that bag of soil around everybody. See how porous that is? That soil freezes much deeper than native soils. So, early season, you get a little bit of water, don't panic. All right, weeds, again, problem, nutsedge. Nutsedge is a huge problem in rain gardens. Rain garden soil is perfect habitat for nutsedge. This is showing a couple problems. This is siltation that came off the parking lot. That is motor oil, gunk, garbage, rubber tire particles that are heading into that drain. Okay? That's the kind of stuff that comes off the parking lots that goes into the rain gardens, contaminates. Now, the other issue is this opening is across from the inlet. It's defeating the whole point of having a rain garden. That opening needs to be upstream from that inlet, letting the water go into the soil. This is, I cannot believe that this thing actually got passed through Conservation District, quite frankly. It's a short circuit. That's the same thing, different product. That's a short circuit. That's the opening right there. They short-circuited the rain garden because the engineer didn't want to be hassled with it. Didn't want to have it not work. You build a rain garden, not getting any water into it. Okay? Both these instances. Now, there's another issue I'll show you. Okay, let's go back. Edge treatment of gravel, good idea. This is going to keep erosion down, keeps washouts from happening. This is sort of an odd slide. This is showing a bunch of runoff, salt runoff. This was in the winter this slide was taken. So you've seen a couple things here. This was actually frozen ground. The roof of the building was, so we're getting a little bit of ponding. This particular rain garden actually dries out within 12 to 24 hours. And I wasn't able to get the finished picture. This thing's green and beautiful, but it gets a ton of salt. Same with this. This is getting a ton of salt. This also shows a blowout here, where this curb cut should be twice this size. We had that much blowout because we had an overrun. The water out of that parking lot overran that curb and eroded it away. So you're going to get blowouts with rain gardens. And there's two ways to deal with them. One is the design side with doing a bypass, and the second way is to do armoring and size the openings correctly, and space out the openings correctly.